So good morning to everyone. Myself Nikhil from SRIT College in CSSC section, and today my topic is need of multi-threaded programming. So first of all, what is a thread? A thread is the smallest unit of execution within a process in a computer system. It is a sequence of instructions that can be scheduled and executed by the CPU. Threads allow a program to perform multiple operations concurrently, enabling multitasking and more efficient use of system resources. A thread is sometimes referred to as a lightweight process because it shares the same memory space and resources as the other threads within the same process, while a process in a independent program with its own memory. Threads are commonly used in multi-threading programming to run tasks in parallel, improving performance and responsiveness. Each thread has its own execution stack, program counter, and local variables, but it shares global variables and other resources with other threads in the same process. So next, define multi-threaded. Threads are lightweight subprocesses representing the smallest unit of execution with separate paths. The main advantages of multi-threads is efficiency, allowing multiple things at the same time. For example, MS Word, one thread automatically formats the document, while another thread is tasking user input. Additionally, multi-threading ensures quick response as other thread can continue execution even if one gets stuck, keeping the application responsiveness. So next one, so see and observe this picture and T1, T2 and T3, these are the threads can exhibit a process P1 and P2. Process P1 లో thread 1 and process P2 T1 and thread can be T2. As we can observe in the above diagram, a thread runs inside the process and there will be context-based switching. Between threads, there can be multiple processes running in OS, and each process again can have multiple threads running simultaneously. The multi-threading concept is popularly applied in games, animations, so etc. So threads can be created by using two mechanisms: extending the thread class, implementing the runnable interface thread creation by extending the thread class. We create class that extends the java.lang.thread class. This class overrides the run method available in the thread class. A thread begins its life inside run method. We create an object of our new class and call start method to start the execution of a thread. Start invokes the run method on thread object. So observe this picture. So extends by using thread class. So thread extends on object and by using two threads, thread A and thread B. So thread extends on thread A, thread B extends also thread A. So thread extends on thread class and by implements by using on runnable class. So next one, a small example of extending and implementing thread classes. So first class name extends on thread. So by using run method to print thread is running, and by using main method string aux create an object myThread t1 equals to new myThread and get start t1 dot start by using start method. So implementing the runnable class, same class name that can be using implements runnable run method print line thread is running. So main method string aux create an object thread t1 equals to new thread new my runnable and next start t1 dot start method by using start method. So needs of multi-threaded, better CPU utilization, first one, and modern processors have multiple cores and multiple threading ensures that all core are utilized effectively. A single threaded applications can leave CPU resource ideal, whereas multi-threading distributes tasks across cores. And second one, improved application performance. Multi-threading allows multiple operations to run concurrently, reducing execution time. Tasks like sorting large datasets, real-time analytics, and image processing benefits from parallel execution. So responsive user interface. In graphical user interface applications like example JavaFX, Swing, and AWT, a single threaded approach can cause UI freezing. So fourth one, faster input-output operations and networking. Multi-threading prevents blocking operations from halting the entire program. Useful in applications like web servers, file processing, and database queries. So fifth one, concurrency in large scale. Applications used in web applications, microservices, and distributed systems allows efficient execution of tasks such as API calls, logging, and background jobs. So real-time processing applications needed in applications such as gaming, AI competitions, stock market analysis, and simulations. Thread help handle multiple tasks such as rendering, graphics, and processing inputs simultaneously. So finally conclusion, multi-threaded programming is essentially for building efficient, responsive, and scalable applications in Java. It allows developers to maximize the resources utilization and improve user experience through concurrent execution. As software demands continue to grow, the need for effective multi-threaded solutions will become increasingly important. And finally, thank you to everyone.